Hello, hello, hello students. Today we are going to discuss important problem in circular motion. Let's start. A wheel is subjected to uniform angular acceleration about its axis. Initially, its angular velocity is zero. Initial angular velocity of the wheel is zero. In the first 2 seconds, it rotates through an angle theta 1. In the next 2 seconds, it rotates through an additional angle theta 2. The ratio of theta 2 to theta 1 is. This question can be solved directly without using the pen also. In case of uniform acceleratory motion, when initial velocity is 0, the angle traveled will be in the ratio of in same time interval 1:3:5:7, and you can see from the numerical calculation also. In first 2 seconds, angle traveled is theta 1. Initial angular velocity is 0. So we will be using theta 1 equal to half. Alpha is constant. T square time is 2 seconds. So this angle is coming to alpha. This is equation 1. Now dear student, in time t equal to 0 to t equal to 4 seconds. Let us assume angle traveled is theta 2 dash. So theta 2 dash will be equal to half alpha t square. Here no need to calculate any initial angular velocity because we have taken reference time as t equal to 0. So this is how much? This is 8 alpha. So angle traveled in next 2 seconds, which is asked in the question, that is from t equal to 2 to t equal to 4 seconds. Angle traveled is theta 2. This is equal to theta 2 dash minus theta 1. This is equal to 8 alpha minus 2 alpha. This is equal to 6 alpha. So in the question, what is being asked? Ratio of the angle traveled theta 2 upon theta 1. So our answer will be theta 2 upon theta 1 will be equal to 6 alpha upon 2 alpha. This is equal to 3:1. So out of 4 options, the correct answer is option 3. Option 3 is the correct answer. The linear and angular acceleration of a particle are 10 meter per second square and 5 radian per second square, respectively. It will be at a distance from the axis of rotation. Dear student, what is relation between linear and angular acceleration? When any body rotates, the relation between linear and angular acceleration is A equal to R alpha, where A is linear acceleration and alpha is angular acceleration, and R is the distance from the axis. Distance from the axis. So dear student, in the question, linear acceleration is given 10 meter per second square. Angular acceleration is given 5 radian per second square. So we can write 10 equal to R into 5. So R will be equal to 2 meter. This is our answer. So out of 4 options, the correct answer is option 4. Option 4 is the correct answer. The ratio of angular speeds of minute hand and hour hand of a watch is. This question can be solved directly. The minute hand needle makes one revolution in 1 hour and the hour hand needle makes one revolution in 12 hours. So definitely the minute hand needle will be moving. This is the minute hand needle makes one revolution in 1 hour. Okay, and hour hand needle makes one revolution in 12 hours, means it will be moving 12 times faster. Okay, and if you want to calculate by mathematically, omega can be written as delta theta upon delta t. If we take time interval to be same for minute hand needle, omega 1. This is for minute hand needle. Let us take time. Let us take same time interval, means we are taking 12 hours. Okay, in 12 hours, how many revolutions it will make? The minute hand needle makes one revolution in 1 hour. In 12 hours, it will make 12 revolutions. While in case of hour hand needle, 12 revolutions on the 2 pi. 12 revolutions means how much? 2 pi radian. And in case of hour hand needle, this will be how much? 2 pi upon delta t. So dear student, omega 1 upon omega 2 will be equal to 12 is to 1. This is the ratio of angular speed of minute hand needle and hour hand needle. So out of 4 options, the correct answer is option 3. Without solving, you can write it directly also. Option 3 is the correct answer. A particle moves in a circle of radius 25 centimeter at 2 revolutions per second. Radius is 25 centimeter and 2 revolutions per second, the acceleration of particle in meter per second square. Since omega is given, 2 revolution, 1 revolution equal to 2 pi radian. So this is 2 into 2 pi radian per second. Means this is 4 pi radian per second. This is omega. And in the question, acceleration is asking in meter per second square. So we have to convert this 25 centimeter into meter. So acceleration will be equal to, since omega is constant, so acceleration will be only centripetal acceleration. Since omega is constant in the question, so there will be only one acceleration, that is centripetal acceleration. Okay. So A equal to omega square R. What is omega? Omega is 4 pi. And what is R? This is 25 centimeter. So this is 16 pi square into 25 into 10 power minus 2. This is 400 pi square into 10 power minus 2 meter per second square. This will give us 4 pi square meter upon second square. This is the acceleration and this is only centripetal acceleration. Okay. So answer is 4 pi square. Out of 4 options, the correct answer is option 3. Option 3 is the correct answer. A particle moves in a circular path with uniform speed. Uniform speed means particle is moving with uniform circular motion. Okay. The change in its velocity on rotating through 60 degree. Dear student, first the particle is moving with uniform speed v. The change in velocity on rotating through 60 degree. Let's see here. You can take any point as reference point. Okay. If we start the journey from here, this is v. Let us say this angle is 60 degree. V always remains tangential. So this is v. Now we have to determine change in velocity. What is meaning of change in velocity? Final velocity minus initial velocity. So this is initial point and this is final point. So let's calculate change in velocity. This is final velocity minus initial velocity. I am telling you the simplest way. Final velocity, add negative of the initial velocity and make vector sum. So dear student, this is direction of final velocity and this is direction of initial velocity negative. Okay, this is minus v initial. This is v final. Okay, this angle is 60 degree. So this angle is also 60 degree. This angle is 30 degree and this angle is 30 degree. Okay, so angle between final and initial velocity is how much? 30, 30, 60, 60, 60, 120 degree. Okay, according to vector addition, when angle between two vector remains equal to 120 degree and magnitude of the vector are same, the resultant will be equal to any given vector, or you can calculate by using the formula also. V square plus 2 v cos 120. Value of cos 120 degree equal to minus half. Okay, that also you can use. So here change in velocity will be equal to v, or you can use the formula v square plus 2v square cos 120 degree, 2v square plus 2v square minus 1 upon 2. This will give us v square. This will give us v. Okay. So out of 4 choice, the correct choice is option 3. Out of 4 choice, the correct choice is option 3. A body is moving with a constant speed v in a circle of radius r. Its angular acceleration, here angular acceleration means centripetal acceleration. Why? Because the body is moving in circular path with constant speed. Okay, whenever speed is constant means motion is uniform circular motion in case of circular motion. Okay, in case of uniform circular motion, angular acceleration is the centripetal acceleration whose value at a given instant is v square upon r. Okay, so dear student, out of 4 choice, the correct answer is option 4, because here in this case tangential acceleration is 0. Okay, a string of length 1 meter is fixed at one end and carries a mass of 100 gram at the other end. The string makes 2 upon 5 revolutions per second around vertical axis through the fixed end. Calculate the tension in the string. Now, if you read the question properly, you can see the string is making 2 upon 5, 2 upon pi revolutions per second means angular speed is constant. And when angular speed in a motion is constant means motion is uniform circular motion and mass of the particle is 100 gram. String length is 1 meter means radius of the circular path is 1 meter. Now we have to determine tension in the string. This is the question. The length of the string is 1 meter and mass of the particle is 100 gram. 100 gram means 100 into 10 power minus 3 kilogram. That means 0.1 kilogram. Okay. And the string is rotating with constant angular speed omega. That is equal to 2 upon pi revolutions per second. Revolutions means this is 2 pi radian per second. So this is 4 radian per second. So how much will be tension? tension in the string will be given as m omega square r, that is equal to centripetal force. Okay, so what is the value? M omega square means 4 square, that is 16, and what is radius? That is 1 meter. So answer will be 1.6 Newton. So out of 4 choice, the correct choice is option 2. Out of 4 choice, the correct choice is option 2. A car is traveling with linear velocity v on a circular road of radius r. If it is increasing its speed at the rate of a meter per second square, means this is a case of non-uniform circular motion, because here speed is increasing, means this is tangential acceleration. Okay, then the resultant acceleration will be, in case of non-uniform circular motion, there are two types of acceleration. One is centripetal acceleration, whose direction is directed towards center of circular path, and another one is tangential acceleration. Dear students, centripetal acceleration is responsible to maintain the particle on circular path, and tangential acceleration is responsible to change the speed of particle, and the resultant acceleration will be given as A equal to AC square plus AT square, because AC and AT are perpendicular to each other. So in our case, centripetal acceleration can be written as V square upon R, because radius of circular path is R, and tangential acceleration in our question is given as A. So we can easily write the equation of total acceleration. This will be equal to V4 upon R square plus A square. This will be the total answer. Okay. So out of 4 choice, the correct answer is option 2. Out of 4 choice, the correct answer is option 2. Okay.